Hello everyone, in this video we're going to learn about the Pythagorean theorem, which is this: a squared plus b squared equals c squared. So I'm just going to draw alternating line segments that are different in length. And I'm going to go around, take a turn at the corner like this. Now these are supposed to be straight lines. Now, so we got a nice looking square here with this pattern. Now we can also draw line connecting from here to here because we know how to do that, right? This is point like from here to here is B, so we know how to do that. And so we can get these points. So we can draw a diagonal connecting those points like so. And we can do that for each of these sides. So what you'll notice is that you actually get 4 congruent triangles here that have been just rotated 90 degrees. Like this triangle is just this triangle rotated 90 degrees. And at each of the corners, the angle is 90 degrees. Now let's work with a nicer looking diagram. So like I said, this is 90 degrees. And let's label some angles here. I'm going to call this angle A, angle B. So if you'll notice, what is this angle? You should notice that it should be angle A, right? And this should be angle B, because like I said, this triangle is just the one that's been rotated 90 degrees counterclockwise from this one. And the same goes for like these other triangles. They're all symmetrical. So what about this angle here? We know that angle B plus angle C plus angle A should add up to 180 degrees. But we also know angle A plus angle B should be 90 degrees because this is 90 degrees and all 3 angles of the triangle should add up to 180. So these two should be 90 degrees, A and B here. So I can do that and find that angle C should be equal to 90 degrees. So this angle is in fact a 90-degree angle. Now that goes for any length of actual A and B. So this covers the general case where A and B can vary whatever. And the angle here of the inner rotated square should stay as 90 degrees. And you should be able to sort of see why each of these other angles should be 90 degrees on an intuitive level as well as visually. Okay, so we know the angles C. Okay, so now what can we do? Let's call this side, one of the sides here, C. So, you know, the reason we've found this angle to be 90, the consequence of that is Now this has turned out to be a square as well with side C. So now what we can do is we can write an expression for the area of the largest square, and we can do that two different ways. We can do it from sort of inside out, like add the area of this plus area of the four triangles, or we can do it just by from the outside, which is a plus b times a plus b, or length times height. So let's just do that. So we have four triangles, and the area of each of those triangles is simply a times b over 2 plus this rotated smaller rectangle square, which should be c squared, should equal to the another way of doing it is a plus b times a plus b. Now let's just expand this. You get 2ab plus c squared equals a squared plus 2ab plus b squared. Now notice that 2ab's here are on both sides, so we can simply cancel it, just get rid of it like this, and we are left with the Pythagorean theorem. Okay, now we can just stop here, but we can also go a little more and get a sense of what this means. So this is the, like I said, the area of the larger square. This is also the area of the larger square, just calculated differently. And when we remove a term from here, it's no longer the area of the larger square. It's something else, right? So what is that something else? Does it have a meaning? Yeah, it kind of does, because anything squared is just a square. So we can just sort of extend this and say this represents this, and this represents the other square. And when you add them together, you get, this is C, so you get this thing, exactly this bluish looking square. Add this square and this square together, you get this bigger square in terms of area. So that's interesting, because you might have wondered, if you add two square numbers, like, can that get to a square number? And this shows that, yeah, that kind of thing is sort of possible. Okay, thanks for watching this video, and I'll see you in the next one.